Today our topic is transfer function. What is the transfer function? For any control system, there exists an input terms at excitation or cause denoted as R. So input signal is R, which operates through a transfer operation term as a transfer function denoted by G. Suppose this is transfer function G, and produces an effect resulting in the output or response term as control variable denoted by C. So what is the transfer function? So transfer function is a ratio of, so transfer function is denoted by TS or it is denoted by FS. It is depend on book. What is the notation? What is the notation? Notation is TS, FS, XS, etc. But what is the definition? Laplace transform of output signal is CT, and Laplace transform of input signal is RT. So this ratio is called the transfer function. So what is the definition of transfer function? Laplace transform of output signal and Laplace transform of input signal, it is called as a transfer function. So ratio of Laplace transform of signal, Laplace transform CT, it is nothing but a CS, and T is converted into S, and Laplace transform RT is RS. So TS is equal to Laplace transform of output signal divided by Laplace transform of input signal. So this is a transfer function. Input signal RT is applied in this transfer function. Okay, in this system, output is CT, input is GT. So many times it is called as a GT. So Laplace transform of GT is equal to Laplace transform of CT divided by Laplace transform of RT. So GS is equal to CS by RS. This is the formula for Laplace transform. So some students are confused about this T and S. So T is the time domain index, S is the frequency domain index, S is nothing but sigma plus minus j omega, where sigma is real function, j omega is imaginary function, and this S is represented on S plane. So in this S plane, sigma, the x axis is real axis, y axis is imaginary axis, j omega minus sigma. But in the transfer function, we only convert T into S. So what is the Laplace transform? So the Laplace transform is a mathematical tool which convert input RT into RS. So Laplace transform is a mathematical tool which converts the time domain signal into frequency domain signal. So this is called as a Laplace transform. And inverse Laplace transform, it is also mathematical tool which convert the frequency domain signal. So what is the frequency domain signal? RS into time domain signal. What is the time domain signal? RT. So here this S is called the frequency domain index and T is called the. So finally we know that this GS is gain, it is called as a forward gain, RS is input and CS is output. Only remember the transfer function, or it is also called as a gain, is equal to output by input. So output क्या हो गया? CS. So CS is the Laplace transform of output signal, RS is Laplace transform of input signal, okay, and Laplace transform of GT is nothing but a GS. So there is one standard equation for a transfer function. What is the standard equation for transfer function? So standard equation is, so GS is equal to CS by RS. Everybody know about this formula. Here many times some books used AS, BS, etc. So don't concentrate on this term, only concentrate on a standard equation. CS by RS is equal to A0 S raised to n plus A1 S raised to n minus 1 plus A2 S raised to n minus 2 plus and so on. And finally an S raised to n minus n matlab 0. So S raised to 0 is always 1. Then similarly B0 S raised to m plus B1 S raised to m minus 1 plus and so on. So what is the last coefficient? It is Bm S raised to m minus m. M minus 1 is equal to 0. S raised to 0 matlab 1. So into 1. So this is the standard equation. And when we take a fraction of this equation, so we obtain one constant k, s minus s1, s minus s2 and so on. Last factor is s minus sn divided by s minus s0, then s minus sb, a, b and so on. Last factor is s minus sm. So this is called as a factor of this equation. For example, quadratic equation हो जाएगा a0 s square. Suppose a0 is 1, तो s square plus s plus है ना 5 etc. Similarly, so this is one quadratic equation. And how to determine the factor? It is using by the formula minus b plus minus under root of minus b square minus 4ac divided by 2a. You know the formula, minus b plus minus under root of b square minus 4ac divided by a, where ax square and x is equal to ax square plus bx plus c is equal to 0 for this equation. So we determine the roots factors by using this formula. Here k is nothing but it is a0 by b0 is known as gain factor of transfer. The denominator part is called as a poles of a transfer function. This numerator part is called as a zeros of a transfer function. In many books we consider here n and here m, and m is always greater than n. So it is depend on you where you using here m or here n. For this equation, m is always greater than n or is equal to n, then it is called as a valid transfer function. If m is smaller than n, it is called as a invalid transfer function. So always convert such type of transfer function or such type of factor into this factor. Means the highest power of s polynomial is always greater in highest power of s polynomial in numerator. So denominator highest power of s polynomial is always greater than the numerator of highest power of s polynomial in numerator. Now next part is properties of transfer function. There are a lot of property of transfer function. We discussed some main property of transfer function. The first property is that, so write down, dear student, write down in notebook the first property. The transfer function is defined only for linear time invariant system. So it is defined for only linear time invariant system. Linear time invariant system. So what is a linear time invariant system? Linear system are those systems which output input characteristics linear. Time invariant means when we change the input signal by some factor plus minus k, then output is also changed by the same factor plus minus k. Such type of system is called time invariant. So transfer function is defined only for linear time invariant system. If suppose there is a non-linear system, this transfer function will fail for that system. Next is all initial conditions are 0. This is the second condition. All initial conditions are 0. So this is the second property of transfer function. It is also drawback of transfer function because all initial conditions are 0. Third is the system stability can be described in terms of location of the roots of the transfer function. So it is a very important property. The system stability can be defined in terms of the location of roots. So location of roots, we take a previous equation where s minus s1, s minus s2 and so on are the zeros of transfer function. S minus sa, s minus sb are suppose poles of a transfer function. So here s is nothing but a complex variable. So we represent these poles and zero in a s plane. So you get s plane, j omega axis in y axis, in x axis it is called as a real axis. Initial origin is 0. So here s minus sa is equal to 0, that means s is equal to sa. So here s is equal to sa. So sa is positive. Positive means, and remember that poles is always represented by this cut mark x, and zeros is always represented by a small circle. So your s minus sa, you get sa, sb and so on. Similarly s minus s1, so s is equal to s1. So s is equal to s1, s2, s3. So s1, s2, s3, these are the zeros and these are the poles. s1, s2, whatever the value. Okay. So this is called as a presentation of poles and zeros on s plane. So what is this property? The system stability can be described in terms of the location of roots of the transfer functions. So there is some rule that if suppose your roots are laying left half of s plane, name of this plane is s plane, so the system is referred as a stable system. If your roots located on right half of s plane, it is called as a right half of s plane, as your system is unstable. And in suppose your roots located on imaginary axis, it is called as a marginally stable, neither stable nor unstable. Okay, so it is called as a marginally stable. So with the help of location of roots, we decide here system stable or not. So this is one property of transfer. Next property is related from characteristics equation. The characteristics equation, one question arises in our mind: what is characteristics equation? The equation shows the character of a system. Character of system means stable, unstable. Such type of equation is called as a characteristics equation. So here in transfer function there is a one numerator and denominator. So denominator is equal to 0 is called characteristics equation. For example, s square plus 2s plus 3 divided by s cube plus 2s square plus 3s plus 5 is equal to 0. So s cube plus 2s square plus 3s plus 5 is equal to 0 is called characteristics equation. So denominator is also denominator is equal to 0 is called as a characteristics equation. Next property is that sixth property, in transfer function the time domain index is called t, frequency domain index is called s, where s is equal to sigma plus minus j omega. This is the imaginary part and real part. This is one property. Next property is compensator. Compensator. So there are three types of compensator: lead compensator, lag compensator, and lag lead compensator. When transfer function in this type of form, s plus a divided by s plus b, so such type of transfer function is called as a lead. This is the transfer function of one compensator. Such type of compensator is called lead compensator. For lag, transfer function lag is equal to b s plus a divided by a s plus b, where a is always greater than b. Such type of equation is called used for a lag compensator. And lead lag compensator, s plus a1 s plus b2 divided by s plus b2 s plus a2. So such type of form is called as a lag lead compensator, where b1 is greater than a1 and b2 is greater than a2. So there are a lot of advantage of this transfer function. The first advantage is, with the help of this transfer function, we know the input and output relation. How? Here output is equal to transfer function into input. How it is, how it relate? If suppose a transfer function having 20 units and your input is 10, so 20 into 10, it is 200. Output is equal to 200. So it shows only the relation between input and output. Now we solve one university problem. What is the problem? There is one differential equation: d square yt by dt square plus 3 dyt by dt plus 2 yt is equal to xt plus dxt by dt. Okay, there is one question, and determine transfer function. Okay, there is one question. In this question, determine transfer function, where yt is equal to output, xt is equal to input. One system is there, input is xt, output is yt. So determine the transfer function. So from definition, what is the transfer function? It is transfer function is equal to Laplace transform of output divided by Laplace transform of input. This is our main formula. So take the Laplace transform of output and then Laplace transform input. So assume this is the equation number 1. So take Laplace transform of equation number 1. So Laplace transform of d square yt by dt square plus 3 dyt by dt, then Laplace transform, then plus Laplace transform 2 yt is equal to Laplace transform of xt plus Laplace transform of dxt by dt. So always remember that d raised to m xt divided by dt raised to m. So Laplace transform is s raised to m xs. So always remember this formula. So here plus there are initial condition. So here initial condition is 0 for a transfer function. So always remember the s raised to m xs. So here d square yt by dt square. What is the transfer function? What is the Laplace transform this term, first term? So it is s square, स्क्वायर है ना, 2 है तो 2, 5 रहेगा तो 5, yt का ys प्लस 3, then Laplace transform of dyt by dt. Here only the power of derivative is 1. So here s raised to 1 ys plus Laplace transform of yt. So it is nothing but ys is equal to, here Laplace transform xt is xs plus Laplace transform dxt by dt sxs. So this is the one equation. Then take the common ys and xs. So we take a ys and a common ys. So it is s square plus 3s plus 2 is equal to xs. So it is 1 plus s. And finally the transfer function ts is equal to, so here we change the term ys in right hand side and bring this xs in also left hand side and this part, this factor in right hand side. So finally ts is equal to ys by xs is equal to 1 plus s divided by s square plus 3s plus 2. So this is the final answer. Why we rearranging this term, then ys is here and xs? Because this is the definition. Transfer function is Laplace transform of output signal by input signal. So this is the final answer.